What does ancient liquefaction evidence in geology tell us? Imagine a landscape that looks peaceful today but hides secrets from thousands of years ago. When geologists find signs of ancient liquefaction, they uncover stories of past earthquakes that shook the ground hard enough to turn solid soil into a flowing, liquid-like state. Liquefaction happens when loose, water-saturated soils lose their strength during intense ground shaking, causing the soil to behave like quicksand. This process can create telltale features such as sand blows, where sand and water burst out of the ground, or cracks filled with sand called sand dikes. These features can stay buried for thousands of years, waiting for scientists to discover them. By studying these ancient signs, geologists can pinpoint where big earthquakes once happened long before written records existed. For example, they might find layers of sand that have been pushed up through cracks or buried beneath other sediments. These features often link to major seismic events, like the earthquakes along the Cascadia subduction zone or the New Madrid seismic zone. Mapping these features helps scientists estimate the size of past quakes and understand how often they occur in a region. Ancient liquefaction evidence also shows how the ground responded during those earthquakes. Features like folded sand layers or lateral spreads reveal that the shaking was strong enough to deform the Earth's surface. Sometimes, faults or cracks in the ground are visible, showing how the Earth shifted during the event. These clues can even connect to well-known historical earthquakes, like the one that struck the Pacific Northwest in the year 1700. Knowing about these ancient signs is important because it helps us understand which areas are likely to experience similar ground failures in the future. If a region shows evidence of past liquefaction, it means that, during a strong earthquake, the ground could behave the same way again. This information guides engineers and city planners to improve building codes and design infrastructure that can better withstand future quakes. Recognizing these old signs of liquefaction helps communities prepare and reduce the damage caused by earthquakes and related ground failures.